All right, so what we want to do here is we want to talk about BGS girls. All right, the BGS is the Berkeley Guided Study, and what it did was it basically tracked kids from age 2 to age 18, measuring weight, BMI, all these different things. What we're going to use this example for is to look at how sometimes differences or understanding how growth works over time can manipulate a model and what actually unique information is. So here's what we're going to do. We're going to have weight 2, weight 9, and weight 18 be our variables, and we're going to try and predict somebody's body mass index, BMI, at age 18. We're going to calculate your growth from age 9. So how much weight increase did you see from age 2 to age 9? That's going to be DW9. And then we're going to look at DW18, your weight increase from 9 to 18. Now, we're going to fit 3 different models here. One with all the weights, one with all the differences, and one with everything in it, okay? And we're going to look to see what these models come out to be. So here's model 1. Get everything read in here. Model 1, Model 2, Model 3. And then we're just going to compare the coefficients. Now, I want to show you something here. We'll see some things. So let's take a look at Model 1, which comes from these estimates right here. What we're going to see is there's an intercept, our slope, -3 at age 2, positive 0.03 at age 9, positive 0.2 at age 18, right? Take a look. Here's standard errors to go with it. But take a look here. Why is this model different? Why is this model different than the first model? Why are the model for estimate 2, ES2, this is the estimate for Model 2, different than that of Model 1? All right. Well, what's coming into play here? What's coming into play here? Well, take a look. Weight 2 can be found in 2 different variables, right? If you look at how weight 2 was created, or weight 2 can be found in weight 2, but if you look at how DW9 was created, there's a piece of it in here, right? There's a piece in here. So what this is saying is the interpretation of these 2 models, though they contain the same information, is different. So if you take a look here, what we're saying is, as weight 2 increases, here's what you see in BMI at 18, given weight 9 and weight 18 are fixed. But here's what you're saying for Model 2. You're come over here and say, fix weight 2, increase it 1 unit. Well, if you increase this 1 unit while leaving all others fixed, what are you doing here? You're leaving this difference the same. So automatically you've increased what? Well, increase weight 2 1 unit. For that difference to stay the same, you've got to increase weight 9. And then for that difference to stay the same between 18 and 9, you've also got to increase weight 18. So what you're doing is you're having interpretability. You're changing the interpretability, okay? You're saying let's fix weight 2 and now the difference between weight 9 and weight 18 and say you put on 1 more pound. You put on 1 more pound at age 9, or you grew 1 more pound. You had 1 more pound larger. That's easily interpretable for DW9. So it's really thinking about what these models are. And then finally, what happens when we put all these variables in? We know there's the same information in DW9 as in weight 9 and weight 2. DW18 is just weight 18 minus weight 9. So what's that look like? Well, let's take a quick glance at the summary output of that model. Because notice, it has the exact same coefficients as estimate 1. So what's that look like? Well, if you look at it, it's going to have this NA. And what that means is the information's aliased. It's already in there. You're trying to add completely, exactly redundant information. 2 not defined because of singularities. Now, there's a lot of issues. And that first one is, notice, if you look back and look at all that math, I say X transposed X inverse, or the predictor matrix times the predictor matrix, transposed times the predictor matrix, has to be able to be inverted. It can't be if the same information is contained. It's called a rank deficient matrix, okay? Now, that's where these NAs come from. Basically, are saying, okay, I can create the same model with these 3 coefficients as adding the other 2. So what it says is these are alias. So if you ever see these NAs pop up, what it says is you're trying to put the same information in, or you don't have sufficient information to add these. The whole point of this little talk is just to remember there are different ways to put the same information in the model. You can think of this as growth from 9 to 2, from 2 to 9, excuse me. Growth from 9 to 18. All these different things matter, guys. All these different things, the way we look at our data, the way we think of our data. If we increase weight 2 1 unit, well, if we try and have the biggest 2-year-old we can, here's what's going to happen at BMI 18. If we have the biggest 9-year-old we can. But don't you think there's a difference between how we grow? Maybe the growth matters more. So when you're looking at this, it's all, and I can't stress this enough, it is all dependent on the way you need to interpret your data. What is most important? Is the actual weight the most important or the growth? You know, maybe if you put on all your weight late, that says something. Or if you're just big in general, that says something. So this is what you need to start thinking about. This is useful for measuring growth of portfolios or customer growth or things like that as well. All right, guys, let me know if you need anything.